In this part of the lecture, the tutor focuses on 3 practical things that come up early when learning Laravel: installation issues and version mismatches, what common HTTP error codes actually mean, and a clear explanation of the MVC pattern that Laravel follows. The tutor's first point is practical. Even if installation looks successful right now, that does not guarantee everything is perfect. Some issues only become visible when you start running commands, starting the server, or building features. So the class continues forward, and if errors appear later, like the next day, students should bring them up at that time. A concern students often have is whether installing or updating Laravel-related tools might damage older projects. The tutor reassures them. If the old project still runs, that's a good sign. But the important warning is that version differences can still create issues in the new setup, even if older work continues to function. The tutor gives a very common real-world example. Sometimes a tool or dependency updates automatically. In the example, Laravel version 13 appeared, while the tutor is still using version 12 for the course. That mismatch can lead to confusing errors, because commands, defaults, or dependencies may behave differently between versions. Next, the tutor explains status codes. These are the numbers you see in web development, especially when working with routes, pages, and APIs. Each code has a meaning, and the first digit groups them into categories: 200s for success, 300s for redirection, 400s for client-side errors, and 500s for server-side errors. For the 200 range, the tutor highlights the basic idea. It means success. The most common one is 200 OK. When you request a page or data and everything works, the server responds with a 200-level code and returns the content you ask for. For the 300 range, the tutor explains that it indicates redirection. Instead of directly returning the final page, the server tells the browser to go to a different location, like when a URL changes or when a site forces HTTP to HTTPS. Then the tutor moves to the 400 range. These are client-side errors, meaning the problem is usually in the request coming from the browser or front end: a wrong URL, a missing route, a typo, or an incorrectly formed request. The key idea is the server is reachable, but what you asked for is not valid in some way. A specific 400-level example discussed is 404 not found. This means the resource is not available, typically because the route or page does not exist. For instance, if someone tries to open an address like /aboutus, but there is no route or page defined for it, the server responds with 404. The tutor addresses a common confusion students have. Sometimes they think a missing page and a code bug are the same thing. They're not. A 404 means the link or route itself is missing. But if the link is defined and the server finds the route, yet the code fails while building the response, that is typically a server-side error, often in the 500 range. Now, the tutor labels the other category clearly: server errors. In the 500 range, the request can be correct and the route can exist, but the backend code throws an exception or fails during processing. The tutor also notes that different server errors can look different. Each has its own pattern and message, so reading the error details matters. The tutor gives a beginner-friendly rule of thumb. When you see a 4XX error, first check the link, route, or request, because it often means the client asked for something invalid or missing. When you see a 5XX error, first check the backend code: controllers, views, models, and the error logs, because the server failed while executing code. A student asks a very practical workflow question. If one terminal is already busy running a command, how do you run another command? The tutor explains that it's normal to use multiple terminals. For example, one terminal runs the Laravel development server with PHP Artisan Serve, and another runs the front-end build tool with npm run dev. And you can open a third terminal for additional tasks. The tutor demonstrates the simple action. In the terminal interface, there's typically a plus button. Clicking the plus opens a new terminal tab or pane. You can keep pressing it to create as many terminals as you need, so you don't have to stop a running process just to type another command. Next, the tutor introduces MVC, the pattern Laravel follows. MVC stands for Model, View, and Controller. This is a way to organize a project so each part has a clear responsibility. Views handle the user interface, models represent data, and controllers connect the request to the right logic and response. The tutor emphasizes the main reason frameworks like Laravel feel easier to manage: organization. In MVC, each part has its own job, so changes stay contained. If you're working on the front-end design, you can focus on Vue files without needing to modify unrelated backend code. That separation makes maintenance and debugging much simpler. The tutor explains the view part first. The view is the front end, the part the user sees. It includes templates, layouts, and page structure. In Laravel, views live in a dedicated views folder, and when you're changing the design or page layout, you're typically working in Vue files. Then the tutor explains the model. It represents data. In many Laravel applications, a model corresponds to a database table, like a user model representing a users table. Models are used to retrieve data and save changes back to the database, so they form the bridge between your application logic and stored data. Finally, the controller is the coordinator. It receives the request, decides what should happen, uses models to fetch or update data, and then returns a view to the user. So when a page loads correctly, it's often because the controller successfully connected the request to the right data and the right UI template. The key takeaway for now is to keep the roles clear. Views are for the UI. Models represent data, often tied to database tables. And controllers handle the request and coordinate between the two. Next, the tutor will continue building on this structure as the project work becomes more hands-on. Next, the instructor focuses on version updates and why they can suddenly cause lots of errors. The example used is Laravel. Version 13 exists, but someone might still be using version 12. A key point is that when you create a brand new project, it often uses the newest version by default, so you may not notice anything until you open an older project. And the bigger the jump, like going from version 10 straight to 13, the more likely it is that you cannot just update casually. That large gap usually means you need to follow a more careful step-by-step upgrade process. Here, the instructor separates two cases. If the difference is small, like Laravel 12 to 13, it's usually smoother. There may still be changes, but it's less likely to completely break everything. But if the project is very old, like version 10, and you try to jump to 13, that's a big gap. In that situation, more things have changed, so errors are more common, and the instructor emphasizes that you must follow a specific process, rather than hoping an automatic update will fix everything. For the upgrade process, the first concrete step mentioned is to update Composer. Composer is the dependency manager Laravel relies on, so if Composer itself is outdated, you can run into problems when trying to update Laravel packages. The instructor's approach is straightforward. Go to Composer's official documentation, download the updated installer, and install it, using the same method they used previously in class. The instructor adds practical installation notes that often cause confusion in real environments. If the computer is behind a proxy, the proxy URL option may need to be enabled during installation. And if antivirus software is active, it can sometimes block installers or scripts Composer uses. So the message is, if installation fails unexpectedly, don't assume the steps are wrong. Sometimes it's the network proxy or antivirus interfering. Then the discussion shifts to terminal workflow. A student asks how to open another terminal, and the instructor demonstrates that multiple terminals can run at the same time. The key action is using the plus button. Each time you click plus, you get a new terminal session. This is useful because in a Laravel project, you often want one terminal running the PHP development server and another running the front-end build tool, like NPM. The instructor's example setup is very typical. One terminal runs the backend server using PHP Artisan Serve, and another terminal runs the front-end tooling using npm run dev. The reason to separate them is simple. Both commands keep running continuously. If you run them in the same terminal, you can't easily keep both processes active at once. A student asks an important habit question. Every time you open the project, do you need to run the commands again? The instructor explains the practical reality. If you refreshed, closed the terminal, or reopened the project and the processes are no longer running, you must start them again. A key troubleshooting clue is the browser message, "This site can't be reached." In this context, the instructor teaches students to immediately suspect the PHP Artisan server is not running. The instructor reinforces a workflow habit. Before running anything, you must be inside the correct project directory. That means using CD to navigate to the project path first. Only after you're in the right folder should you run PHP Artisan Serve or npm run dev. This prevents a very common beginner mistake, running commands from the wrong directory and wondering why nothing works. Along with terminal habits, the instructor emphasizes being aware of the project's location, its path. The idea is, first, confirm you're inside the project folder, and then open that folder in VS Code. This builds consistency. You always know where your code lives, and you reduce confusion when switching between multiple projects. Next, the instructor explains how database interaction fits into MVC. The view is the front-end portion, what users see. The model represents the database tables, and the controller is where the logical code and functions belong, especially the code that decides what data to fetch, what to store, and what to send back to the view. This separation is meant to prevent everything, front-end, back-end, and database logic, from becoming mixed together in one messy place. The instructor's motivation is about reducing complexity. If database code, UI code, and application logic are all mixed together, it becomes difficult to maintain and easy to break. MVC helps by giving each part a clear job. That structure keeps code shorter, more organized, and easier to debug when something goes wrong. A concrete example is given. If there is a users table, there's typically a user model. The model is the code representation of that database table. So instead of writing raw database logic everywhere, the model becomes the main place you interact with that table's data in a structured way. The instructor explains what the model is used for in practice. If you need to add new data, you do it through the model. If you need to retrieve data, you can fetch it through the model. And if you need to change existing records, the model is also the pathway. The key idea is the model is the main interface between your application code and the database table it represents. The instructor clarifies the meanings again in simple terms. View refers to the front-end pages, the user interface. Controller is where the logic goes, functions, decision-making, and especially the code that handles database operations, like fetching records or inserting new data. This is also where you keep your application behavior organized, instead of scattering it across routes or views. The instructor points out a real example from the lesson. A function was written directly in the web routes file. That can work, and the instructor acknowledges that functions can technically be written in different places, but the recommended, organized approach is to move that logic into a controller. The reason is maintainability. Controllers are designed to hold those functions, keeping routes cleaner and the project easier to manage as it grows. A student asks whether MVC is only used in Laravel, and the instructor clarifies that it's a general pattern used in many frameworks. The terminology stays consistent: model, view, and controller. So learning MVC here is valuable beyond just one tool. It's a reusable way of thinking about how to structure applications. The instructor warns about a common misunderstanding. Some people try to directly equate MVC with front-end, back-end, and API layers. While there can be some overlap in how it feels, that mapping is not exact. MVC is specifically about organizing responsibilities in code, what handles display, what handles logic, and what represents data, rather than being a strict definition of deployment layers like API versus front-end. To make MVC intuitive, the instructor references our restaurant analogy used earlier. The view is like the dining area, what people see. The model and database are like the kitchen and chefs, where the work with data happens. The controller is like the waiter, taking requests and returning results. But the instructor is careful. It's not a perfect one-to-one definition, just a helpful way to build intuition. The instructor sets expectations for how the class will proceed. Right now, the focus is on views. After that, the class will move toward models, and then controllers, step by step, one at a time. This matters because MVC concepts are easier when learned progressively. First, understand what the user sees, then how data is represented, and finally, how logic connects the two. At the end of this segment, the instructor mentions a reported installation problem from someone in the class. The .env file was not created during setup. The instructor flags it as something to address later because it's slightly off the current topic. But it's an important note. Environment configuration is critical in Laravel, and a missing .env file can prevent the app from connecting to the database or running properly. Next, the lecture can pick up by diagnosing that kind of setup error and the typical fixes. Picking up from the setup process, the next practical step is making sure Composer is updated, then reinstalling the Laravel installer the clean way, and finally running a Laravel project correctly, meaning the PHP server, the front-end build tools, and the database service all need to be in the right state. First, Composer needs to be the updated version. The straightforward approach is to go to the official Composer documentation site, download the latest installer, and run it. Basically the same installation approach as before. While installing, only use the proxy URL option if you truly have a proxy. Otherwise, leave it unchecked, because incorrect proxy settings can cause download and install issues. Two common causes of Composer installation errors are proxy settings and antivirus. If you don't use a proxy, don't tick the proxy URL option. Otherwise, Composer may fail to fetch packages. And if an antivirus is installed or running in the background, it can block Composer's actions. In that case, temporarily disable it during installation. If there's no antivirus on the machine, then there's nothing to change. Once Composer is installed and working, the next steps happen in the command line, cmd on Windows or a terminal on macOS and Linux. The key idea is first remove any older Laravel installer that might already be installed globally, and then install the latest one. This avoids version conflicts, where an old installer keeps generating old project structures. The first command is to remove the old Laravel installer. In Composer terms, that means uninstalling the global package. The purpose is simple. If an older Laravel installer is present, it gets deleted so it can't interfere. This is the clean slate step, and it should be done before installing the new installer. After removing the old installer, the next command is to install the latest Laravel installer globally using Composer. This replaces the old setup with the new one. Conceptually, you've now ensured the system will use the current installer when you create new Laravel projects. Next is creating the project, but there's an important practical reminder. Laravel projects typically depend on a database, and the database service should be running when you're working, especially once you start migrations, authentication scaffolding, or anything that touches the database. If the database isn't started, you may not notice immediately, but you'll hit errors as soon as the app tries to connect. For project management, the folder you open matters a lot. You should open the Laravel project root, the folder that directly contains things like the app folder, routes, vendor, the artisan file, and composer.json. A common mistake is having an extra nested folder level, like opening a parent folder and then having the real Laravel project inside another folder. That nesting can cause you to run commands in the wrong place and wonder why nothing works. A good habit is to first navigate to the project path in the terminal and confirm you're in the correct directory by checking for Laravel's key files, like artisan and the app and routes folders. Once you've confirmed that, then open that exact folder in VS Code. This simple routine prevents a lot of path confusion later. To run the project, one core command is starting the Laravel development server. That's done with php artisan serve. When it starts successfully, it gives you a local URL, commonly 127.0.0.1 on port 8000. This is the backend server that handles routes, controllers, and the Laravel application logic. In many Laravel setups, you also need the front-end build process running, especially for CSS and JavaScript. That's why a second terminal is used for npm run dev. With this running, changes to front-end assets get compiled and refreshed properly. So a typical workflow is one terminal for PHP artisan serve and another terminal for npm run dev. A practical habit is keeping a third terminal open. Terminal A runs the backend server, Terminal B runs the front-end dev process, and Terminal C is there for any extra commands you need, like running migrations, clearing caches, generating keys, or anything else. This way you don't have to stop your running processes just to type a new command. There's also an alternative, Composer Run Dev. The idea is that instead of manually running PHP artisan serve and npm run dev in separate terminals, this single command can run both processes together, so it starts the backend server and the front-end dev builder in one go. In practice, whether you use Composer Run Dev depends on your environment. On macOS and Linux, it often works smoothly and is convenient because it reduces the number of commands you manage. On some Windows setups, it can feel slower, so many people prefer the separate terminal approach for better responsiveness and control. Two small but important command line habits. To stop a running process, use Ctrl+C. That works for the Laravel server, the npm dev process, and also Composer Run Dev. And if you want to clear the terminal screen on Windows, the command is CLS. These make it easier to manage your terminals while developing. Alongside the servers, the database service needs attention. Even if the site loads, the moment Laravel needs to read or write data, it will try to connect to the database. If the database service, like MySQL through XAMPP or another setup, is not started, you'll see connection errors. So it's part of the standard checklist when starting work. A reported issue during installation was that the .env file was not created. That's a common kind of setup problem, and it often points to environment differences, permissions, or the way the commands were executed. The next part of the discussion focuses on what this can look like on Linux systems. On Linux, the setup often needs to be done directly from the terminal, and some actions may prompt for your password. Permissions can affect whether files get created properly, like the .env file. So if someone is installing on Linux and sees strange behavior, a first suspicion is permissions and whether the commands were run in the correct directory. Next, the focus moves into troubleshooting, how to diagnose installation problems like a missing .env file, what differences to expect across Windows, macOS, and Linux, and why a terminal-first workflow tends to be the most reliable when something unexpected happens. Continuing from the previous steps, the instructor's point here is that the database gets fully cleared first, meaning the old records are removed, and then the new correct data is inserted again. They refer to this as the second step. After that, the third step is straightforward. Move on to creating the project. The key idea is that a clean database state prevents confusing errors later, because you're not mixing old tables or old records with a new project setup. Next, the instructor emphasizes a practical requirement. When creating and running a new web project, the local server stack needs to be running, otherwise errors show up. In typical setups, if Apache and the database service are already running, the project starts normally and nothing looks wrong. But if something is stopped, like the web server or the database, then the project can fail immediately. So the habit to build is, before blaming your code, first check whether the required services are actually started. They give an example of how an error can happen even if you think you did everything right. You might type the database connection value incorrectly. In many frameworks, there's a configuration value like DB connection. If you write the wrong driver name, the system tries to connect using something that doesn't match your environment, and you get a connection error. The instructor's point is not the exact file name, but the pattern. Small configuration typos can cause immediate failures that look scary but are often simple to fix. Then, the instructor contrasts MySQL with SQLite. If the project is configured to use SQLite, the setup can be simpler because SQLite is file-based. In that case, you often don't need to run a separate database service like MySQL at all. PHP can work with SQLite directly. That's why they mention that when they used SQLite, the earlier error didn't appear. The teaching point is, choosing SQLite for learning or small projects can reduce moving parts and reduce the number of environment-related errors. Now the instructor shifts into command execution habits. One quick command mentioned is CLS, which clears the terminal screen. The goal isn't that clearing the screen fixes the program. Rather, it helps you read what's happening by removing old output. Especially when you're running multiple commands and errors keep stacking up, clearing the screen makes it easier to see the newest message and diagnose the current issue. They also mention that sometimes you run 2 commands to get things working, but on macOS you might be able to skip some of that if your dependency tooling is already set up. The instructor references Composer, meaning PHP's dependency manager, as a way that some environments can automate parts of the setup. The important lesson is, don't assume everyone runs the exact same commands. The required steps can change depending on the operating system and how the tools were installed. The instructor repeats a key operational point. The services have to be started. If you're using a traditional stack like Apache plus MySQL, both need to be running before you test the project in the browser. If you're using SQLite, then MySQL doesn't apply, but PHP still needs to be available. This is a workflow discipline. Start services first, then run the project, then debug code. Otherwise, you waste time debugging an error that's actually just a stopped service. Next, the instructor talks about what to build in the project, not just a couple of pages. They mention that only 3 pages were created so far, but the practice should be to create the full set, whatever the design or requirement list includes. They specifically call out pages like Home, Contact, Courses, Upcoming, and Blog. The learning goal here is repetition and completeness. Building multiple pages forces you to practice routing, navigation links, layout reuse, and consistent structure across the whole site. Then there's a Linux-specific discussion. The student notes that on Linux, the XAMPP graphical interface doesn't seem to run properly. The instructor's explanation is that this can happen when the XAMPP version is old and doesn't support the newer Linux version. In that situation, relying on the GUI can be frustrating, and the practical solution is to manage the services through the terminal instead. A key detail for Linux is permissions. When you start or stop system services, Linux often requires administrative privileges, so you'll see password prompts. That's why the student mentions needing to type a password in the terminal. The instructor's implied guidance is, this is normal. Use sudo when required, and provide your system password to allow the command to run. They also discuss what to do if the Linux setup still doesn't work. The instructor suggests messaging with details so they can investigate, especially the exact error message and the Linux version. They also suggest checking the group to see if someone else has Linux and can confirm the steps. And if needed, they propose coordinating a specific time, like around 11 o'clock, to troubleshoot together. The broader lesson is, when environment issues are hard to reproduce, you need clear error details and a coordinated debugging session. Finally, the instructor mentions pushing the project to GitHub. This is a practical troubleshooting technique. If the code is on a repository, the instructor can pull it, inspect configuration files, and see what might be wrong, without relying only on screenshots or descriptions. They also mention pushing now and reviewing later, which reflects a common workflow. Share the repo, then the helper can check it when they have time and demonstrate the fix afterward. Next, the lecture moves into the hands-on sequence, the exact terminal commands to start the required services reliably, especially on Linux, and then a clearer step-by-step workflow for pushing the project to GitHub so it can be reviewed and shared. The instructor points out a very common situation. An error shows up when trying MySQL, but the same work seems fine when switching to SQLite. That's a clue that the problem may be environmental, like configuration, services, or drivers, rather than a bug in the application logic. In other words, before rewriting code, it helps to ask, is this error coming from the database choice and the local setup needed to run it? They're contrasting SQLite and MySQL mainly from a setup perspective. SQLite is file-based, so it can feel simpler. Sometimes you can get moving with just PHP and Laravel without running a separate database service. MySQL is a server, so you typically rely on a local stack like XAMPP or a similar setup, and that introduces more configuration points. The key teaching point is, SQLite can hide setup problems because it's simpler, not because your code is magically better. Even though SQLite can be convenient, the instructor argues there's a practical downside. If you want to view the database, manage tables, or do admin tasks, you may end up using separate tools and a different workflow. In many typical web development environments, MySQL is used more commonly, so the suggestion is to stick with MySQL for now, and then as experience grows, the differences between these database options will become clearer. For MySQL, the instructor highlights phpMyAdmin as a big convenience. Because it's typically available right inside a local stack like XAMPP, it becomes easy to open a browser tool and directly inspect the database, adjust records, and make changes when necessary. The app still talks to the database through queries, but phpMyAdmin gives you that extra visibility and control during development. So the practical course decision is use MySQL for now, not because SQLite is wrong, but because a shared common environment reduces confusion, especially when everyone needs to follow the same steps. And since phpMyAdmin makes database inspection straightforward, it supports learning and debugging. Over time, as students build experience, they'll naturally understand when SQLite is a better fit and when MySQL is a better fit. A quick but important note appears here, checking the Laravel version. The instructor mentions they forgot to show it earlier, and a student asks how to check the Laravel version. The response is that you check it from the project itself, meaning the version is tied to the project's configuration and dependencies, not just something you guess. Next, the instructor shifts to page creation. The task is to build more pages, roughly 5 additional pages, because only 3 were created so far. The guidance is, if the design includes items like home, contact, courses, upcoming, and blog, then each of those should exist as an actual page in the project. Creating pages isn't enough by itself. You also need routes. The instructor explicitly says to create routes according to the pages, so every page has a corresponding route, and the route loads the correct view. The practical test is simple. When you click a navigation item, it should actually take you to the correct page. A big part of the task is the navigation bar. The instructor's expectation is to build the full navbar design and then include it on every page, so the site feels consistent. The navbar is also functional. The links should be clickable and should correctly navigate to the routes you created. They also emphasize placement and layout. The navbar should match the design, not just exist somewhere on the page. So the task isn't only to create links, but to implement the UI structure properly, positioning, styling, and consistency across pages according to the provided design. Then the instructor touches on collaboration realities. If someone is using Linux, their setup might behave differently, and they might hit different issues. The instruction is to message in the group if there's a problem and then coordinate a time to resolve it. This is a practical reminder that environment differences can affect development steps and error messages. Finally, they mention GitHub. The instructor plans to show how to push the project to GitHub, and if students need it, they'll upload materials or videos. The underlying workflow is the standard one: commit locally, push to the GitHub repo, and then others can access it. And if anyone runs into trouble, the expectation is to raise it early so it can be addressed. Next, the flow moves into the actual demonstration of pushing the project to GitHub and making sure everyone can follow along. The best preparation is to have the pages created, routes connected, and the navbar working, so when the code is pushed, the repository contains a functional multi-page structure that others can run and click through. To continue from the setup work, some versions can be checked directly from the terminal because they are installed globally on the computer, like PHP, Node.js, NPM, and Composer. But Laravel is different. In this workflow, Laravel is installed inside a specific project folder. So if someone asks, what Laravel version are you using? The reliable place to check is inside that project, typically by looking at composer.json, rather than expecting a global Laravel command to exist. The reason Laravel's version is checked inside the project is that Composer downloads Laravel inside the project's vendor folder. That means the framework code is not a system-wide installation. It is a dependency of that one project. So the project's composer.json declares which Laravel version range is allowed, and Composer installs the matching framework version into vendor. A practical warning about where to create the project. If the path shows OneDrive, it's better to create the Laravel project somewhere else, like a normal local folder on C drive. OneDrive syncing can introduce permission problems and unexpected file locking issues, which can break installs or cause confusing errors. After creating the project, a quick sanity check helps. A Laravel project contains many files and folders, which can feel overwhelming at first, but it's normal. One important indicator is the .env file. If .env is missing, it often means the project creation did not complete successfully and stopped partway through. The .env file is one of the most important files in a Laravel project. It holds environment-specific configuration, especially database settings. It also contains things like the application name, debug mode, and keys used for generating tokens and secure features. Because Laravel reads .env at runtime, even a small change here can change the behavior of the entire project. When using MySQL, the database configuration is set in .env. The key line is db connection. If it's set to SQLite, but the intention is to use MySQL, it needs to be changed to MySQL. Then db host, db port, db database, db username, and db password must match the local MySQL setup. In many starter setups, some MySQL lines may be commented, so the fix is to uncomment the MySQL configuration and ensure the values are correct. A common question is whether the database must be created manually in phpMyAdmin. Manually creating a database is possible, but it's not enough by itself. Laravel also needs its tables. That's why the recommended approach is to use migrations with the artisan command, php artisan migrate. This not only creates the tables Laravel expects, but in many setups, it can also prompt to create the database if it doesn't exist yet. On Windows, the terminal choice matters. In VS Code, the terminal can be opened with Ctrl+J. Many people switch the default profile to Command Prompt, or CMD, because in some environments, PowerShell can cause issues with certain Node or NPM commands. Git bash is also an option. What matters is using a terminal where the needed commands run reliably. The command php artisan migrate is a key step. It reads the database configuration from .env, tries to connect to the database server, and then runs migrations to create the tables Laravel needs. If MySQL is not running, the command will fail, so the database service must be started first. The tables created at this stage are often the default Laravel tables, and later the project will add more as features are built. Is php artisan migrate complains about the database? One of the first checks is XAMPP. If MySQL shows as stopped, it must be started. The admin button for MySQL opens phpMyAdmin, which is useful for confirming what databases exist. The key idea is migrations depend on the database server actually running. In phpMyAdmin, the left side lists databases, and inside a selected database, you'll see tables. It helps to keep the vocabulary clear. The database is the container, and tables are the structures inside it where rows of data are stored. When Laravel runs migrations, it creates tables like users and migrations by default, along with other supporting tables depending on the starter template. If the database name in .env does not exist yet, Laravel can prompt during migration. The prompt typically asks whether to create the missing database, and the default option is often yes. In that case, pressing Enter accepts the default and continues. After that, refreshing phpMyAdmin should show the new database, and the migrations will create the tables inside it. Another practical caution, XAMPP stores its internal components and databases inside its installation folders, like C:\XAMPP. That includes MySQL data and PHP binaries. Deleting or modifying those internal folders can break the entire local development environment, so it's best to treat XAMPP's internal directories as off-limits unless there is a very specific reason and you know exactly what you're doing. Some students try the VS Code Go Live extension, but that's meant for static HTML files. A Laravel app is a dynamic PHP application, and its entry point is public/index.php. Requests need to go through Laravel's routing and framework bootstrapping, so instead of Go Live, Laravel is run using the built-in development server via Artisan. To run the Laravel project locally, the standard command is php artisan serve. When it starts successfully, it prints a local URL, like http://127.0.0.1:8000. Opening that link in a browser loads the Laravel application. When checking which Laravel version a project is using, composer.json is the key file. Inside the Require section, the Laravel/framework dependency shows the version constraint, like *12.0. Composer uses that rule to install a compatible version. You'll also see a PHP version constraint, and that matters because newer Laravel versions often require newer PHP versions. There was a note about version differences. Some jumps, like Laravel 9 to 10 and 10 to 11, introduced bigger changes. But for learning the core workflow, routes, controllers, views, database migrations, the differences between nearby versions usually won't stop progress. The main constraint is often PHP compatibility. If the environment only provides a certain PHP version, that can limit which Laravel version can run comfortably. Once PHP artisan serve is running, that terminal session is actively hosting the app. If it's stopped, the browser link stops working. So the habit is to keep that server terminal running and open a second terminal tab, using the plus button, whenever other commands need to be executed. At a high level, Laravel handles a request through a simple flow. A user hits a URL, Laravel matches it to a route, the route points to a function, often a controller method, and that function returns a response. Very commonly, the response is a view, meaning an HTML page, but it doesn't have to be. It could be JSON for an API, a redirect, or something else, depending on what the route is designed to do. Next, the task is to design a complete navigation bar using Tailwind CSS. The goal is not just to draw the nav bar, but to make it reusable across pages, create the required routes for each page, and ensure the links actually work when clicked. If any issues come up while implementing it, those will be addressed in the next session while building it step by step. There was a request to explain MVC. The quick framing is models represent data and database logic, views are the user interface templates, and controllers handle incoming requests and decide what response to return. In Laravel, routes often point to controller methods. This becomes more concrete when building multiple pages with a shared navbar, because routes and controllers will coordinate which view to show for each link. Picking up from the flow, a user starts with a URL. That URL is matched by a route. The route runs a function, often a callback, and that function returns a view. The browser doesn't magically find a file by itself. It needs that route mapping, so Laravel knows what code to run and which view to render. The key idea is that any page you want to show, meaning any view, must be reachable through a URL. In real websites, people don't type file names. They click Home, Courses, Upcoming Classes. So we design the app so each view has a URL, and Laravel routes that URL to the correct view. When the instructor talks about the main URL versus the part after it, they mean the domain is the base URL, but routing is mostly about the path. The path can be just a slash, meaning the home route, or it can be something like /about or /services. A very common default route is the slash route. In routes/web.php, you define route get slash, then a function runs, and it returns view welcome. That means when the path is just slash, Laravel renders the welcome view. Views are stored under resources, then views. So welcome is typically resources/views/welcome.blade.php. That blade file is basically where you write your page markup, mostly HTML, with blade features available when you need them. A blade template is simply a blade file where you can write normal HTML. For example, you can create about.blade.php and write a standard HTML structure inside it. Later, you can add blade features, but the starting point is, yes, you can write HTML directly here. In plain HTML projects, you could open a file directly using something like LiveServer, but a blade file is meant to be rendered through Laravel. So to access a new page, you don't just create the view, you also create a route so the framework can serve it through a URL. To create an about page, you define a new route, like /about. The callback returns view about. One important rule, you can't define the same URL path twice. Each path should be unique, otherwise you'll create conflicts and unexpected behavior. The function you place directly inside the route is a callback. Because it's written inline, it usually doesn't need a name, so it's an anonymous function. If you moved that logic somewhere else and wanted to call it later, then you'd need a named function or a controller method. Once the routes exist, you test them by visiting the URLs. The home page is just /. The about page is /about. In local development, you'll often see something like 127.0.0.1:8000 and then the path you want to open. In real usage, people won't type /about manually. They'll click something, so we add navigation links like welcome and about. So clicking changes the URL, Laravel matches the route, and the correct view is returned. A simple way to create navigation is using anchor tags. In a Blade view, you can write a nav element, then add an anchor with href/ for the welcome page, and another anchor with href/about for the about page. If you want navigation to work everywhere, you place the same nav markup on each page. So the welcome page has the nav, and the about page also has the nav. Then no matter where the user is, they can click to move between pages. Next, the instructor moves into styling with Tailwind CSS. In many Laravel setups, Tailwind is already included. You confirm that by checking package.json. Also, remember, package.json and composer.json are where dependencies live, and along with the .env file, they're considered extremely important project files. Instead of using a CDN link, Laravel commonly uses Vite. The idea is, if Tailwind and your CSS are already in your project, you don't need to load them from someone else's server. You add the Vite directive in the head and point it to resources/css/app.css. Vite can load multiple assets. You can list the CSS file and also a JavaScript file, separated by a comma. If you're not using JavaScript yet, it's okay to include only the CSS entry. Just keep the syntax correct. To actually make Tailwind work during development, two processes are typically running. One is PHP artisan serve, which serves the Laravel app. The other is npm run dev, which runs the Vite development script and compiles Tailwind and other assets. You usually keep both running. If you write Tailwind classes and nothing changes, a common fix is to restart the Vite process. Stop it with Ctrl+C, run npm run dev again, and refresh the browser. Local development can sometimes lag, so restarting the asset pipeline is a practical troubleshooting step. For productivity, the instructor mentions terminal shortcuts in VS Code. Ctrl+J toggles the terminal panel. Another common shortcut is Ctrl+Shift and the backtick key, which is usually located just below escape. These shortcuts help you quickly manage multiple terminals. At this point, the recommended practice is straightforward. Create several views, then create the corresponding routes, and finally add navigation links so the pages are reachable by clicking. This repetition is what makes the routing and view concept feel natural. For example, if a services page is needed, the first step is creating a new view file in Resources Views, like services.blade.php. The important part is the Blade extension, because Laravel expects views in that format. Then you define a route for it, for example, /services, and return view services. Notice the difference. The route path is the URL users type or click, while the view name is the Blade file name, without the .blade.php. This is where many beginners get confused, so it's worth separating the three names. The link text is just the label users see. The href is the URL path, and it must match what you defined in routes. The view name inside View of Services must match the Blade file name. They can be similar, but they are not the same concept. After adding the route in View, you update navigation so users can reach it. Add a services link with href/services. And if you want consistent navigation, you place this nav on the welcome page, the about page, and the services page as well. A direct question in the material is, why do we put links in web.php? Because that file is specifically for the website side, routes that return views. Console.php is for command line tasks and automation. And later, there are separate route files for APIs. But for normal pages, web.php is the correct place. The instructor emphasizes that editor extensions are important. With the right extensions, you can control-click on a view reference and jump straight to the file. You also get autocomplete suggestions and clearer error highlighting, which speeds up learning and reduces mistakes. Route is not just a random word, it's a class reference, commonly used as a facade in Laravel. That's why you'll see an import like use illuminate support facades route. If that import is removed, the editor and the code may not know what route refers to, and you'll see errors. When route becomes red because the import is missing, the editor can help you fix it. You can use Control Space to open suggestions, then choose the correct route class from Illuminate Support Facades. This kind of quick fix is largely powered by extensions. The material recommends installing extension packs for Laravel, specifically Laravel Pack and Laravel Extension Pack. For PHP, install PHP IntelliSense and PHP IntelliFence.
The packs may include some extras you don't use immediately, but they usually cover the main features you need for Laravel development.
If you're unsure how to find the extensions, the practical approach is open extensions and search for Laravel to find the Laravel packs, and search for PHP to find PHP IntelliSense and PHP IntelliFence. Then install both PHP ones if they're not already installed.
A common surprise is that after enabling Tailwind, the page can look like everything went default. That's because Tailwind applies a reset, often called preflight, which normalizes styles. So you need to actively add Tailwind classes, text sizing, spacing, layout, to build the design.
If Tailwind still doesn't apply, check two things. First, the Vite directive must be correctly placed in the head and spelled correctly. Second, npm run dev must be running. If it hangs or stops reacting, stop it with Ctrl-C and start it again. There's also a mention of npm I. That command installs dependencies listed in package.json and creates node_modules automatically. In many Laravel startup projects, Tailwind is already configured, but npm install is still the standard step to ensure all node dependencies exist locally.
A question raised is whether Tailwind must be installed separately on the server. The instructor's point is, if you deploy the project, the setup goes with it. In practice, deployments often include an asset build step, but conceptually, you're not treating Tailwind as something separate from the project. It's part of the project configuration.
Next, the instructor continues from these basics into building more pages, doing more realistic design work with Tailwind, and dealing with project-level issues and errors as they come up during development.
In Laravel, routes are usually separated by purpose. Web routes live in web.php, and they're for the website side, pages a user opens in a browser, where Laravel often returns a view. API routes live in api.php, and they're for endpoints that typically return JSON for apps or JavaScript. Here, the focus is the website, how a browser URL in web.php ends up showing a blade view.
A good mental model is a pipeline. The user types or clicks a browser URL. Laravel matches that URL to a route defined in routes/web.php. That route returns a view from resources/views, and the view renders into HTML that the browser displays. So views are the front-end content, and routes are the links that provide access to that content. Laravel allows you to point more than one URL to the same view. For example, both / and /welcome could show the same welcome page. But in most normal projects, that's a bad habit. It confuses people, it increases maintenance, and it creates multiple entry points to the same content, which can also complicate SEO and tracking. If there's a real reason to support two links, the cleaner approach is to pick one canonical URL and redirect the other to it. So if someone lands on /welcome, Laravel can redirect them to /, and then / is the single route that actually returns the welcome view. That way, you still support both links, but you keep one true source of routing logic. A route runs automatically when its URL is accessed. You don't manually execute the route like a normal function call. The browser requests something like /services. Laravel's router looks inside web.php for a matching definition, and then it executes that route's action immediately. When you're on PHP Artisan Serve, Laravel starts a local development server. As you click around, it logs the requests, like get/services, get/welcome. That log is a helpful clue. It confirms which URLs are being hit and in what order, especially when redirects are involved. When returning a view, you call it by its view name, not by the full file name. So you write return view services, and Laravel finds services.blade.php automatically. If you write services.blade.php in the view call, Laravel won't resolve it the way you expect, because dots have a special meaning in view naming. In Laravel, dots in a view name represent folders. For example, view.services.index maps to resources/views/services/index.blade.php. That's why adding .blade.php into the string breaks the convention. Laravel interprets the dots as directory separators, not as part of a literal file name. It's completely normal to organize views into subfolders. You might have a Pages folder for general pages like Welcome and About, and a Services folder for service-related screens. Then you reference them using dot notation, like view.pages.about or view.services.detail. This keeps projects clean as the number of pages grows. If you visit a URL that doesn't exist in web.php, you'll get a 404, page not found. The meaning is simple. Laravel has no route for that link. Usually, it's either because you never created the route or because there's a spelling mismatch between what you typed and what you defined.
The fix is either to define that route or correct the URL. A very common beginner issue is defining one path but visiting another. If the route is defined as /about, but you type /aboutus, Laravel won't guess what you meant. It will return 404 because that exact path is not defined. Routes must match exactly. Another frequent error is not a missing route, but a missing view. You'll see something like view about not found. Then you check. Does the blade file exist under resources/views? Did you spell the view name correctly in view::about? And if it's in a folder, did you use the correct dot notation? One nice thing is Laravel usually shows you the exact file and line number where the problem happened. Whether you see detailed error pages depends on configuration, commonly via the .env file. In local development, app debug is often true, so Laravel shows detailed stack traces and line numbers. But in production, you typically set app debug to false, so users don't see internal details. That's an important security and professionalism step when deploying. A practical observation: sometimes when an error happens, the page may load for a while before the error appears. If it's taking unusually long, assume it's a real issue that needs fixing. Maybe something looping, something misconfigured, or something that's not resolving, rather than assuming it's always just a tiny typo. Those numbers, like 404 and 200, are HTTP status codes. A 200 means the request succeeded, route matched, view rendered, everything okay. A 404 means the resource wasn't found, most commonly because the URL doesn't exist in your route definitions. These codes are standardized, so they carry consistent meaning across the web. There was also a setup style question about whether the server is automatically installed. The key idea is you have the Laravel project code, and in development, you run it locally by starting a server, commonly with PHP artisan serve. The project is what you place on a server when deploying, but during development, you're usually just running the app on your own machine. Finally, the material points out that Laravel follows the MVC pattern. M is model, data and business rules, often connected to the database. V is view, the blade templates that produce the UI. C is controller, the layer that handles requests and coordinates between models and views. This structure is one reason Laravel projects stay organized as they grow. To wrap up, web.php is for website routes. API.php is for APIs. Routes are the URLs people access, and they often return views, which are the front-end templates. Try not to create multiple URLs for the same page. Redirect if you truly need alternatives. When calling views, use the view name and dot notation for folders, not the .blade.php extension. And when debugging, remember, 404 usually means the route is missing, while view not found means the view reference or file is wrong. All of this fits into Laravel's MVC structure: models, views, and controllers working together.